So far, we covered two meanings of the term angle. And we mentioned that there are three meanings of that term. The third one was the measure of rotation. So now I want to focus on the third meaning of the term angle. Before that, however, I need to explain to you the meaning of the term rotation. Now, I'm sure you know from real life what rotation is, but I want to explain what's the mathematical meaning of the term rotation. In fact, the situation is a little bit unfortunate here as well. The term rotation refers to two distinct mathematical objects. Just like angle refers to three distinct mathematical objects, so the term rotation refers to two distinct objects. The first one is the notion of a continuous rotation. This is a gradual, with respect to time, transformation of space. What you should think of is, you should think of this point here. Here's the point B. And you should think of that point as it travels through time. So I'm assuming not only the presence of a geometric plane, but also the presence of some time, and that time is passing by, and my point B changes its position with time. So that transformation, that law of motion, would be called a rotation, a continuous rotation, or just rotation. And then there is a second meaning of the word rotation, which is an instantaneous transformation of space. So it is so whether you carry out a continuous rotation or unusual rotation or an instantaneous rotation, the end result is the same. However, when you have a non-continuous rotation, the transformation is instantaneous. There is no time. You have the point A somehow teleports, if you will, to its position point B. There is no time involved. Everything happens in the same time frame. So, in mathematics, when we say rotation, without specifying whether it's continuous rotation or instantaneous rotation, so if you just say rotation without any further elaboration, we usually refer to instantaneous rotation, the teleportation kind of business. In physics, however, the term rotation most frequently refers to the continuous version of the rotation. So, and of course, in physics, often time is explicitly parametrized, usually denoted by the letter T. Whether the term rotation refers to continuous rotation or to instantaneous rotation should be inferred from context. Of course, it's possible in mathematics to use the word rotation in the same way as physicists usually do. And physicists, of course, also refer to the mathematical version of the word rotation. So the two are ambiguous. So as usual, we ask the reader to be careful when listening to these terms and to infer their meaning from context.